maybe we will get started since we only have a few seconds. And we have all our panelists here at the same time, on time. No one got lost, amazing. Okay, so we are gonna be talking about efficiency is money, how smart buildings pay off, but we're gonna do a little bit of a different spin on it, because as I'm sure you've seen, we talk about efficiency all the time. And every time I bring up efficiency, it's like, oh, well, efficiency's done, and now we're on to like low carbon, and we're on to all these things. And it's a bit interesting because I have a lot of my clients. I'm based in Canada. Well, I'll get everyone else to introduce themselves, but they're like, oh, you know, with this shift in political environment, are you feeling demoralized that we're shifting a little bit away and back to efficiency? And my answer is, well, I actually think that we think that efficiency is dialed, but it is very much not. So that's what we're gonna talk about today, is more like the gap in what we think efficiency is done and where it actually is and how we can bridge that gap. And so obviously that equates to money, but we're really gonna talk about, you know, what's missing from efficiency. So I have 4 lovely panelists here. I'm gonna get them to introduce themselves briefly and just talk about, you know, how they fit in here and how they see the gap in efficiency based on kind of the industry and the area that they work in. Maybe we will start on the end with Terry and go backwards.
Okay, Terry Herr with Intellimation. We're out of the Mid-Atlantic region. Used to be a regular SI, I would call us. In the last maybe 10 years, we shifted to an MSI that focuses on energy retrofit work. So leveraging typically the building automation system. So energy efficiency is what we do every day, typically by optimizing the existing building automation system or installing a supervisory device over top of that.
My name is Scott Graham. I'm from Vancouver, Canada. I'm a design build, solar thermal and domestic hot water for apartment building contractor. I actually have utilized controls and the domestic hot water heat pump to salvage heat from many different areas within the building and re-inject it back into the hot water system.
Hi, I'm Danielle Radden. I work for an AI company called Facil.Ai. We optimize central plants using the power of AI.
I'm Abby Massey. I am principal at Capstan. We are a specialty tax incentives consulting firm. So we specifically focus on federal incentives here in the US and help to partner with our building owners as well as our design and construction teams to make these incentives possible.
All right, so you'll see we have a pretty big range of people using efficiency at different levels. So we've got Terry, who's kind of on the fault detection pieces. We've got Scott, who's using the standalone controllers. We've got Danielle, who's AI. And then we've got Abby, because as of the last 2 AHRs, everyone wants to know what's happening with incentives. So don't worry, there will be lots of time for questions. I will let you raise your hands at any point, and one of our team will bring around a mic. I'm totally fine for you to ask questions throughout. This is meant to be really interactive. We can kind of pivot whichever way we want to go. Really briefly, so that you know why I keep chiming in and adding things, I'm a consulting engineer, and so we focus a lot on efficiency, mechanical design, so I'll kind of be chiming in a bit, but mostly I'm gonna let these people talk. So, nobody has questions yet, I'm gonna start. I'm gonna start with AI, I think.
Oh boy.
So, and I feel I cannot be the only one who thinks this, but I feel like AI is very like, oh my gosh, look at all these things we can do. And I'm like, okay, but like, what is it that you're actually doing? So we've got Danielle, we're gonna talk about it. So first I wanna understand, because I wanna talk about this efficiency gap. And I'll just explain what we're seeing is that people are addressing efficiency as a like, I've done efficiency and now I'll come back to it in 5 years and it'll just work in between. It'll keep going. All of my sequences will stay in place. All of my savings will happen. It'll be wonderful. And literally last week, I had done a project with a client. We had implemented all these sequences. I went back, 6 weeks later. The operators had overridden all of my sequences. The system was running 24/7. Were we getting savings? No. Were they improving comfort? No, because they didn't talk to sustainability. We weren't achieving any savings. I was like, I'm so glad that we did this big study and this implementation. What a great idea. So this is what we're going to talk about a little bit. And I want, Danielle, for you to talk a bit about what you're seeing the gap of AI, or sorry, what you're seeing the gap of energy efficiency, if it's similar, and how you see AI supporting that.
Awesome, thank you. Oh goodness, energy efficiency. We have a tendency to think that if we've reached the guideline 90.1, or we've reached the guideline 2007, I can't remember all the guidelines. Once we've reached some guideline, we've made it, wipe our hands, walk away. But the thing is that we have a tool that you can plug in, and it can sit there and monitor every minute, every 5 minutes, every 10 minutes, every day, whatever the best outcome is for you, and it can adjust to make your equipment run absolutely as efficient as it possibly can for the conditions that you're in that very moment, with direct feedback, more so than a PID loop ever could. And we're not taking advantage of that. And I think there's a lot of expectations that AI is the same thing as ChatGPT, that somehow, we go in and we use AI because we can talk to our AI chatbot, and we can talk to Alexa, and we can talk to Google. And I'm sorry if I made anybody's phones go off, I apologize. But really, there's so many types of AI, and AI doesn't need language. And I'm going to go off on a tangent. I'll come back, I promise. Way back in 1950, Alan Turing said the test of intelligence in an AI is that we would be able to talk to it, and we wouldn't be able to know that you're talking to a computer. That's the test of intelligence. And so somehow in the last 70 years, we've equated communication with intelligence, but that's not true, because computers speak in numbers. They speak in math. And if you can give a computer a number and say, you know what, random computer, central plant chiller, I want you to have a kW per ton of 0. It doesn't understand the language, but it understands that 0 goal, and it's going to drive to do that as hard as it can. It never will, but it's going to keep trying and trugging along. So we really have the wrong expectations of what AI should do, in that we keep thinking it needs to communicate with us, but what the AI needs to do is communicate with the equipment and talk in the terms that the equipment understands. Okay, I'll be done.
No, that's great. Thanks, Danielle. That's wonderful. And I think just to bring it a little bit back to in practice, not that that was great. But, for example, when I say my operators overrode everything, it's like, oh, bad operators. But actually, what are they doing? They're getting comfort complaints. They're managing 42 buildings. They're trying to maintain operations. That's probably what I would do too. I would probably be like, stupid sustainability. It makes my job harder. It introduces complex equipment. It causes comfort complaints. I'm going to override them. You could see how that happens when not properly managed and when they're not properly supported. And it is not reasonable for me to ask an operator to be like, watch this dual fuel rooftop unit. Make sure that it is in heat pump mode. And when it's not, I want you to make sure you switch it. And then I want you to call sustainability and call me. And I want you to work with me to fix that. And they're like, I don't have 5 hours. I have 3 seconds to fix this comfort complaint. So I was talking to Danielle earlier, and she's like, yeah, well, our AI, it's watching that dual fuel rooftop unit. It's saying, oh, you should be in heat pump right now. Oh, your gas is firing too high. Oh, you're above set point. Those are the things that we want to continuously monitor. And I think one of the messages that I would like to make is that efficiency, it shouldn't be like a one and done. It really needs to be a continual monitoring. And I think that's where AI is helpful, because it is very unrealistic to ask any of our operators, building managers, anyone to continually monitor their equipment. Even with trends and stuff, there still takes somebody. So I'm off my soapbox, I'm done now. I would like Terry to chime in here, because he's working a little bit more in the fault detection, analytics, and I know you've talked a little bit about embedded training with operators and how to support them. So can you maybe chime in on any of that part?
Sure. Just to just to chime in on the AI thing a little bit. So I'm a controls contractor for a long time, and for many years we've just been programming controllers one time, and they don't learn. They just do the same thing over and over and over again. That's been the standard for 35 years in the digital control worlds. What I've seen in the last couple of years is that Guideline 36 has come out, and that's definitely a leap forward to better sequences of op, but we're still hard coding that into a controller that doesn't learn. In the last, I'd say 2 years, I've seen, and I'll use the term machine learning because I think for our purposes, that's a subset of AI. That's really what most of AI is doing in our space. So for instance, PNL had a researcher. They have this tool called Neuromancer, and it does differentiable predictive controls. Now, there's a couple terms in the AI world that if you've asked me a couple of years ago what they were, so differentiable predictive controls is kind of like AI. I consider it sort of like model predictive control, but using a gray box model. And then there's a researcher at Syracuse who's doing physics-informed neural networks. Again, AI. These are all machine learning methods. We've seen examples of that already. Facil.Ai is doing it. BrainBox has something. There's a company called Phaedra that is doing plant optimization, so it's definitely coming. Your comment on operators overriding, so mostly currently we are doing optimization based on Guideline 36. We'll just, and we think we're getting probably 80% of the savings, and maybe AI will get us the other 20%. That's sort of my prediction right now. But operators, one of the things that we've learned in doing this work for the last decade about is that you really have to engage the operators some way or other, or they will be your worst enemy in terms of overrides. And you're right, they have a comfort focus, and they are putting out a lot of fire, so it's not unusual. We try our best to engage the operators. Oftentimes, some of this gets sold higher up and gets pushed down on the operators, and so they're reluctant. So we try to engage them. We try to train them. Even simple Guideline 36 sequences, which do something like automatically adjust the condenser water set point in real time. Operators, most of them don't understand that, much less a piece of AI deciding very sophisticated what to do. So it is, and I'm not sure that I'm not sure that we'll get them to understand what AI is doing. We can get them to understand what model predictive control is doing, and we really have to do a better job of deploying it such that it doesn't make mistakes. Because the first time it makes a mistake or does something wrong with the algorithm, it gets overridden, typically for good.
Thanks, Terry. So we've talked, about the more advanced ways to do efficiency, and I think you always hear that like a good operator is going to outperform any system, and I think that that's probably valid. If you had an operator who could sit there and do the things and knew the whole building, like they would have a really great system. And I work with some of those people that are really on it. They're really engaged in retrofits. They're monitoring things when things go wrong. They interact with us. So my question is, because I've had this before, I've had this exact question from clients, like, I've got my system pretty dialed. Like, we are quite efficient. Our operators are engaged. We've got all of AHR 36.1. Like, we are dialed. How is AI still for me? Is their question?
Absolutely. First of all, if you think that a human can keep up with AI, there's no way. There's no way. We like to talk about Lemonade, the new AI insurance company, just partnered with Tesla. If you are using, full self-driving on Tesla, they will give you a 50% reduction on your insurance because it's so much safer. There's no human, if we have 6 million pieces of information coming into our eyes at any point in time, and we can filter and actually use maybe 2% of that, maybe. And that's just to understand what you're focusing on, and everything's happening back there. Like, they're talking over there. I don't know what they're talking about, but I hear it now that I'm paying attention. AI knows exactly what they're talking about, and it's adopting to understand exactly how that's affecting everybody in this room. And it understands that the lighting over there is affecting the lighting over here, and the decibels of the AC over here is affecting how people are hearing in the back over here. And I'm sure the guy in the back doing the sound is amazing. But he has no idea how to use the decibels from the neighboring room. But AI doesn't have a problem with that. And it's the same with our equipment. Every time the AI looks at those numbers, every time it evaluates a sequence, every time it looks at the analytics, if you have a fault detection sequence or system, if you have an optimization system, AI looks at everything and it's not constrained. Oh, and it doesn't need to take vacation for its wife.
Thank you. Now, I promise we're going to talk about more than AI, and my other two panelists, I'm going to get you to talk about a lot of things, because the way I see it is it's sort of a progression. It's like, I don't have all my trending, my operators aren't engaged, my system is old. I'm not jumping to AI. And so I want to just maybe take a tiny step back. We'll come back to some of this stuff because it's very interesting, and it's always, people have lots of questions about it. But when we say efficiency, I think sometimes people assume it's like, oh, well, I must have a year of trending data. I must have all my points trended. I must have, a fault detection or an AI in place. I must do that. And I've seen that rolled out, and I've seen that fail a lot of times because it's like, I don't have time. My team doesn't have time, so naturally I'll get a new tool and it will fix all my problems. We haven't done an AI one yet too much, but we've done fault detection, we've rolled that out, and it's like, okay, well, there's a lot of nuisance alarms, and some of those are tagged incorrectly, and who's actually watching that? Like, it's still quite operator or whoever intensive. And so I want to take a little bit of a step back and talk about how you can do efficiency if you didn't have any of that. Because I do work with a lot of clients, like, I don't have a BAS. I don't have a dedicated operator. Like, is it still worth it for me to do efficiency? And so I want Scott to chime in a little bit here, because he's coming from a bit more of like a practical perspective, and he does a lot of domestic hot water, CO2 heat pump installs, and he underbids a lot of the other people we work with. And he'll come to me and be like, I've noticed that your drawing should be this way, and if you use this controller and you put this heat pump here, like, it would be way more efficient. So I want, Scott, for you to chime in a little bit on, like, what is the driving force for you to push for those? Are you seeing, you're more competitive, or you're better overall? Do you want to maybe talk about why you push the envelope more than the other contractors would?
So I come from the world of solar thermal, and 10 years ago, 15 years ago, solar thermal was all being put in everywhere. And it was done expensively, but there wasn't really alternatives. Photovoltaics was $15 a watt. And they went in with there was a lot of government support, and they left behind a lot of messes. And the whole industry died, basically. And so I personally believe you have to think that you have to be cost competitive. So I now do domestic hot water heat pumps as well as solar thermal. In fact, if you own solar thermal in a commercial building, you get your domestic hot water heat pump half price because of the infrastructure already there. But now that we have the domestic hot water, they're not cheap. The converting from a gas system, which has gone down in price, to a clean energy CO2 heat pump system. But if we can, I would say the word value stack, add some other things into the process. So where I first came into contact with Stephanie about something was, normally you put the units, it's a monoblock unit that sits outside and produces hot water and potable hot water. So I grabbed one of the 8 units and I put them in the games room. And all summer long, it runs and cools the room for free. No CapEx, no OpEx. It's just a waste product from making hot water. And so much so that the manufacturer of the heat pump actually uses it in his slide deck now, showing. But it actually met their goals for having a cool room in summertime that was air conditioned. I'm also introducing controls into these apartment buildings that normally doesn't have them. and I can produce reports showing that the room was kept cold for the health and safety officer, or that certain targets were met on a system where we had gas in the building for space heating that actually did domestic. We showed that the boiler never turned on for the domestic hot water. And because I'm adding a building management system into the building, there's going to be free IOs in there. So not a lot of extra cost. Throw a couple extra things in there. I don't know, makeup, air, I don't know what it'll be. I suppose that now that we introduce these building management systems into apartment buildings which don't normally have them, then Danielle can get involved, because I've now given her a pathway into the building that was previously run off an aquastat.
Thanks, Scott. So yeah, I think one of the things people think is, efficiency is done, we're looking at low carbon. And I would say, to do low carbon efficiently or effectively, you really need to do efficiency at the same time. And that's what we're seeing with Scott. And so we've done this on a couple of our domestic hot water installs. It's like, oh, our laundry room's also hot. Oh, great. We'll put a domestic hot water heat pump in there and we'll control it based on the thermostat. And now we've added cooling for no extra cost. We've increased the efficiency of our system. Our payback is better. The optics are better. Everyone's happier. And so that's not, he's talking about there are, more advanced controllers, but that's just a thermostat that's built into the domestic hot water heat pump and a little controller on the system. Like, that's not a BAS. We're not running any new control wires, but we're integrating efficiency to make that a more attractive business case for our clients. So efficiency is kind of, across the board. I am going to get to Abby, but I find we have a lot of audience questions too, so I might just hold a tiny bit more. I have one more question, because this I think is the piece, and maybe I'll get Terry to start or whoever has thoughts, but in an ideal world, automation, whether it's fault detection, whether it's AI, whether it's a BAS, it should free up operators' time. They should look at sustainability initiatives and be like, yes, look at all this new data I have, I'm gonna be so free. But that's not really what we're seeing in practice. What we're seeing is that now they have this old data. It actually isn't making their lives easier. Now they're overwhelmed. Many times they're not engaged in it. So we should free them up from making these constant control adjustments and allow them to focus on this proactive maintenance. But I feel like we've been saying this for quite a while now. It's like, oh, you have all this new data, you have all this new trending. Great, look at all the things you can do. But it's like, oh, I'm focusing on nuisance alarms. Oh, I'm doing this. So my question to the team is, how far away are we from that reality? And what do you think is holding us back?
I'll start a little bit. So again, I'm from the building automation space, and I would tell you that it's messy, right? The way we build buildings in the U.S. and the way we install building automation systems is lowest cost. The sequence of op is written by the MEPs who don't really know good control sequences. Guideline 36 is really solving that problem, but oftentimes the buildings are not really programmed that well, and they're not operating well. Probably 90% of the buildings I walk into have a good opportunity to save 30%, 25 to 30% on their HVAC, which is about 13 or so % overall building energy use, just by optimizing that. And if we did the right thing, and I think Keith has said this, I do think we can have an autonomous building, and you don't really need a building operator. Maybe they're changing set points and schedules only, but if a BAS works correctly, it's completely autonomous. So there's no operation that goes on. Now, we don't have that most of the time. And even if we did have fully autonomous at one point in time, this is where FDD comes in, because although the optimization may not break, and as long as they don't override it, it'll stay intact. But other things will break. Sensors will go bad. Actuators will actually break. So FDD is an important part, because the minute one of those things breaks, the automation breaks. So if a very important sensor goes, chilled water supply sensor, outdoor air sensor, it will impact the automation. So deferred maintenance is a huge one. There is very few buildings I walk into that everything is working well. And even when you get it working well, again, if it breaks, if it's not that important or not impacting comfort at the moment, it probably will get deferred.
I'm going to ask Danielle to chime in next because I was just thinking how I was maybe talking to you yesterday or someone else in AI, and I was, saying that exact same thing. It's, our sequences are all set up, but the issue is the CO2 is reading like 1100 and there's nobody there. What's going on? Or the supplier temperature seems to be weird. And so now, like you said, the sequences don't make sense. Everything's running weird. And so I know that AI sort of has a solution for that, which I think is kind of cool. So
yeah, and AI really is. I'm going to try to talk about my product without talking about my product. You can build in a lot of resiliency. So for example, if an outdoor air system goes down, or sensor, goes down, AI can pull information from NOAA. We've got temperature data everywhere, and we have access to it because we have access to the cloud. So we are not hindered by the fact that a sensor goes down. We can continue producing results. And if a actuator goes out, the AI will know that yesterday I made this adjustment and it worked. Today I tried to make this adjustment and now the efficiency isn't going down anymore. I need to stop what I'm doing, reevaluate. Maybe it'll come online. I'll try again in 5 minutes. But it builds you a lot of resiliency. So it doesn't just keep chugging along. It has a lot of awareness of what is happening. And it has the context that we've given it. So it's not running amok doing whatever it wants. It really is.
It has a lot of
intelligence. Yeah, intelligence. So there's definitely resilience that's built in that we don't have to have the humans come in and look at it all the time. Just because we have to communicate with ChatGPT doesn't mean you have to communicate with the AI that's running your building. To Terry's point, this really does need to be in the direction of fully autonomous buildings, and we have that. We just need to depend on the resiliency that AI brings to us. And your first question was how far away? I would say 1 generation. I look at my kids. They are the smartest people. I say they know 10 times more than I do, not because they're teenagers, but because, and yeah, they do know more than me, but they do know more than me because they know how to use the tools and they use them every day. And as my teenagers grow up and enter the workforce, all of the problems that we think are so tedious and time consuming, that's never been a problem for them because they've already built a tool. They used AI to code a tool that helped them solve it before they ever even got to the workplace. So 1 generation away, and a lot of the human inefficiencies go away. And time is money, just like efficiency is money.
Yeah, I think that's an interesting perspective because that is a big impediment right now is, the people managing the buildings aren't necessarily supportive of the new systems, but also I think my message with efficiency would be if you think that your buildings are efficient or your systems are efficient and you can leave them alone and walk away, 1 more generation. So you can't do that yet. You can do it in 1 more generation, but we do energy studies. We look at buildings all the time, and I think probably 90% of the buildings I walk into have scheduling opportunities, like the most basic thing. And they're like, oh, we're so efficient. We have all these high efficiency sequences. I'm like, oh, yeah, but you overrode it for that event, and then it's been running 24/7 for 6 months. So, those are where like fault detection and AI can come in. And Scott, because I know you're doing sort of this ongoing monitoring and maintenance as well, which I think is the gap here. Like this is the efficiency gap, is that we think it's working, so we leave it alone, and then we come back to it every couple of years. We find out, oh, it hasn't been working for a year. I've actually been using 3 times more gas than I thought I was. All those savings I was planning on claiming, I can't do that. And so I know Scott's doing that a bit too, but at a more controller level scale. So how are you doing that? Like catching issues?
So the challenge with domestic hot water heat pumps is there's 8 or 10 of them, and they can all run until you lose 1, 2, 3, and they put an air code on the side of the unit, and the site supervisor, repair technician, who's usually the janitor, doesn't even pay attention to it, kind of thing. So I'm with the entry of a controller into it. I'm now writing some simple code that just simply tells me that there's a problem, that there's no amps and it's enabled. and send me an email. And then I can actually just, what we might call old-fashioned now, text to the person on site, tell me what the error code is. We'll eventually get to a point where we'll have more of that information, but baby steps for now to know that the equipment's not working.
Well, and I think that's really key because, a lot of people are like, well, I'll wait until AI and then it'll be fully automated and it won't matter. But right now, what we're seeing is you're not getting your savings because it's not working. So we've got...
Let me just chime in that there's a big difference between some of the projects that Danielle are working on. Like the Van City in Vancouver, where they harvested heat from the server in massive programs, and apartment buildings. There's millions of apartment buildings, and they're not controlled whatsoever. And first alert is usually a cold shower by someone calling the building manager. So we have to work our way down to the big stock, which is the apartment buildings.
Yeah. Do we have a question? Do you want to, Alicia, or do we have a mic? Can you talk loud? Okay.
I really like Danielle's point about human efficiency, and I think that's where there's a huge opportunity for AI. In the facility environment, we have all these fragmented data sources, whether it's knowledge base, whether it's systems, whether it's asset management, and so forth. So, for me, my perspective is that operational efficiency is king. Yet, in my 20 years, it seems like ROI is always on energy efficiency. My question to the panelists, this is to anyone, how have you guys seen it practically to be justified to improve smart building projects with operational efficiency as a key term?
Stephanie, can you repeat the question, please?
Yeah. So the question was, how can we make operational efficiency more attractive with ROI? And how can we get those projects moving forward? Because you're seeing that operational efficiency is actually, saving a lot of money is really important. Am I reflecting that correctly?
A much greater opportunity to achieve the level of savings for an organization based off of
Operational.
productivity gains, operational efficiency, as opposed to any annual utility reduction, right?
Okay, so you're talking like operational as in not this building system operations, but like the workforce inside the building?
The workforce managing the building.
Sure, go ahead, Keith.
So one of our customers, well, first of all, the Nintendo generation started in 1995. So we're not a generation of different than mid-40s right now. I mean, I said 35 years ago, the Nintendo kids are going to be running these buildings 35 years from now. That time is now. Those Nintendo kids are 45 right now. They're running the building, so we're not a generation away. And also, we have a customer named Kenny Seaton. He's at Cal State University, Dominguez Hills. He just installed, at much expense, the largest heat pump installation west of the Mississippi. And they expected their energy bill to go up. Their energy bill actually went down by $250,000 because of the AI. So not only did the AI help him build capital and have some extra additional OpEx and capital available, it actually reduced the energy of the overall system because of the AI. So we kind of look at it like AI is like a cherry on top. It's table stakes.
So I feel like I remember at our panel last year, we talked a lot about like your costs as a building owner or as a owner of a company are more related to the people and than they are the actual energy bills. It's true. It's a much higher percentage, but it's a much more challenging thing to address. And so it's often something we don't talk about very much. However, when done well, I would say that efficiency should increase productivity in operations because you should be improving indoor air quality. You should be keeping people comfortable. And I always say, well, Last year, I remember Scott Cochran was like, the most efficient buildings are the most comfortable. And I say that to my operators that I work with because I don't want us to be fighting. I don't want to do efficiency at the expense of you getting comfort complaints, of people being like, oh, I have to put a sweater on and I need a heated blanket because they're efficient in this building. Like, that's not how efficiency should look. And I think if that's what it looks like, it's being done wrong. And that's where we create this chasm between the operations and the sustainability team that are like, well, you make my occupants less comfortable. And you're right, it is more important that our workers in the building are more comfortable because that is a much bigger piece of the puzzle.
Stephanie, can I?
Yes, please.
I want to address your question, Sergey, because it all comes down to money. Everything, ROI is such a big deal because it's money. So one thing that I've done in the past is I said, how many open positions are you trying to hire for? Let's remove one of those. What is that, $90,000 a year? Maybe $100,000, maybe $120,000 a year. Let's take all of those jobs to be done and divvy them up to other people because all of a sudden they have more time. Let's take that job off the table. $120,000 a year right there.
Sorry, and why do the people have more time?
Efficiency, because operational efficiency. If you can, that's how you can prove operational efficiency. Sorry.
There you go. Yeah. Do you need a mic? Can you yell? Do you want a mic? There you go. Thank you. It's better to not yell.
Hi, everybody. My name is Damani Eason. I'm a product advisor for Pario Solutions based in Tampa. We build a software platform and a tech stack of controllers and sensors that help drive efficiency in buildings. And as we are looking to scale, one of the things that we're looking to incorporate into our marketing and our value proposition is a story around the tax advantages and the incentives that exist for our potential customers. So my question is geared towards Abby. What does the federal landscape look like, across the United States? What do the regional landscape look like? And at a high level, what's the best way to incorporate that knowledge into our value proposition so it's not just about efficiency, but there's some dollar signs attached to it?
I was just waiting for this question. Go ahead, Abby.
Sure. Thanks for the question. So we've probably got various experiences in the crowd is my take with the incentives, especially the federal level. But if you know anything, there's been a couple of pieces of legislation in the last 5 years that have been passed. So the first was the Inflation Reduction Act, which was enforced in 2023. That enhanced a lot of the federal incentives. We had a lot for renewables. Many of the programs that existed already were enhanced to expand to new building owners or to be larger in value. And then we had the One Big Beautiful Bill last year that has changed a lot of that. If you know anything about the incentives, then you might already know that although the One Big Beautiful Bill did impact a lot of the federal landscape that's out there, there's still a lot of programs that are available and able to claim. So for some of the folks that we're meeting that have just a very, very high level knowledge, they heard about the One Big Beautiful Bill and went, oh, okay, everything's gone, forget it. Federal incentives are out the window, but that's not the case. So I think the first step I would say is getting educated or having a partner who can continue to keep you updated. Legislation changes all the time. Not only is it the big bills that come out that get passed, but what happens underneath that you may not know is a lot of notices and guidances get issued in between that don't require a big change of law that help us shape these programs. And so understanding and having somebody who can help you understand what those program changes are and when they're happening is helpful for the federal space. So I would say to be able to incorporate that maybe like in a sales cycle, knowing which programs are available and what triggers those programs is really helpful. And then having a partner who can help you put dollars on that. Honestly, for some of our estimates, like the 179D program, it takes us a couple hours to put it together, and we can get you something in next day or that week. Now, on the regional and let's say even utility type incentives, you might be more familiar with those, but it does depend on where you're located in the country. But there's a lot of programs that go underutilized. That's just the facts of the matter. We see projects every day that have occurred 2 or 3 years back that triggered a whole host of incentives that could have been stacked, and they're just learning about it today. So I would say understanding the regions that you work in, there's some great websites online that will tell you exactly the programs that are available by state, whether it be utility programs, state or city type programs, and the federal programs as well. So utility programs, I would say, are the easiest. Usually they're prescriptive, meaning you get a certain rate per installation of light or thermostat, something like that. But they're also prescriptive programs as well. So having partners in those spaces who can say, we will make a custom solution based off of the project and the energy efficiency. Having these people as a key part of your team, resources that you use, I think is the best piece of advice that I can give you. We see this type of incentive, especially on the federal level, with the amount of nuanced rules that you have to have in your project. The sooner we can come on and help advise on that, the better that project's going to go, the more you're going to be able to claim, and the happier that building owner is going to be because of all of the money that they found up front. So we partner with sales teams all the time to help them identify and understand, okay, what are the triggers for these incentives on all the levels? How much is the value, so that we can communicate that early?
I can add a little bit on at least Mid-Atlantic and Northeast region utility incentives. That's where we operate, and I will tell you there is an area we almost never do an energy efficiency project without a utility incentive. Best place to go for them is actually the utility's website, because they do evolve pretty quickly and change a bit, but every state in the Mid-Atlantic, I mean, Maryland has great incentives. They'll actually pay for about 75% of the cost to do what they call a building tune-up, what P&L calls a retuning. I think NYSERDA, I mean, literally every state, and then there's cities and now states that have policies that are mandating carbon reduction. So New York City has local law 97, probably the strictest in the country. Washington, D.C., and now Maryland State has a mandate. Now, that's not, I think the big areas for that are sort of the Mid-Atlantic and Northeast and the Northwest. And I think there's parts of the country where the incentives are nil. You know what I mean? But certainly, so you can focus in certain geographies, and I think the incentives are really excellent for energy efficiency.
Now that we've pivoted over to incentives for a bit, does anyone have other questions related to this? I want to focus on it for a minute if we have some more questions. I know Abby's a hot commodity right now with all the uncertainty. No more questions right now? I have a question. So you would work kind of on a team to help them, you're going through an energy efficiency program, you're going through a retrofit. Let me support you to find those incentives. And then once they get the incentives, are they typically using them, they're covering the capital retrofits? Are you seeing that money being invested back in? How are people using that? What would be the best way that they would use those incentives?
Sure, that's a great question. And I think this is also where planning with the higher level folks in the organization that's going to be receiving the incentives is really helpful, because think about it, federal incentives typically come through as a tax credit or a tax deduction. So the accounting team is going to see that. They're going to apply that to the overall business. And then if nobody is really talking about it, that's just where it's going to land, right? Profitability for the business. So instead, what we've done is we partnered with some large organizations who have maybe 2040 goals towards net zero or whatever it might be. And as a part of those conversations and plans, it's talking with the accounting team and the facilities group together to say, listen, if we implement these projects and they trigger these incentives and we know roughly that these deductions or credits are going to impact the business in this way, can we then agree that our facilities budget can then go up every year if we're to guarantee that these are going to come down the line? And so I think it takes a coordination with several stakeholders within the business, but I've yet to see a team that we've talked with in this regard not be receptive to it, right? It's good for the business, it's good for the buildings, and if we get the facilities team budget increase, that means more projects down the line, that means more incentives down the line. And so this is just a really nice cycle of being able to be sure that these projects are happening. We're not value engineering out all of our energy efficient features.
Yeah, I think that's so great. And what a great way to get facilities buy-in. Yes, question. Thank you.
Hi, David Eason. I'm with Pario Solutions. This is actually my son. So he is that generation that you're talking about. I had to bring him, on board. So he's actually an advisor, a board advisor to the company. But what I'm curious about, Abby, is how are we going to drive these solutions in? So what I have seen is I've gone into buildings, and they're buildings that are like large, older supermarkets that are now gyms with shared airspace, and they have, 17, 20 RTUs on the top. But without having access to the data, so we put in the sensors, basic stuff, and we start to realize that there's some funny stuff happening with the current consumption, right? So we see the current not varying regardless of temperature, set point, anything. And you start to go in and you realize, oh, this is a faulty, compressor or something like that. So what I'm curious about is, from a tax incentive perspective, are there programs that will help building owners to be able to acquire this data? Because, I'm bringing this stuff to the building owners and I'm showing their plan guys, say, hey, you have a problem here, and these actuators are not even working. So you think they're working and they're not, so are there programs like that?
Yeah, I think from the federal space, not as much, but when you get down to the state and local programs or the utility programs, some of them do have incentives for retro commissioning or energy audits as a part of it. What triggers then after that, though, could be federally incentivized. So if you were to do that report, then come back and say, listen, this is the equipment that we need to replace, or this is what we would make changes to in the system, and here are the incentives that then would be triggered from that on the federal or state or utility level. That's the other thing I always like to note to folks. A lot of people are most comfortable, at least from what I understand in the industry, on the utility level. We've got a lot of people utilizing those. But as you get higher into some of these incentives, they know them less, and so they're often disregarded, but these incentives often stack together. So there's really no reason why you couldn't take the utility incentive maybe for the retro commissioning, but then also, let's say, the 179D deduction for making energy efficient improvements in the building. Both of those can come together on one project.
Anyone have anything to add on that?
I'm just going to comment on the 179D, and I don't know a lot about it, but I know enough that when it's used, it's incredibly lucrative. Now, if you're doing work, though, for government buildings, they typically cannot, if I'm not mistaken, they can't take it. So you end up, I know of contractors, mechanical contractors, controls contractors, you really have to have a profitable business to make a 179D tax deduction valuable. But it can be, and most of the governmental facilities will basically defer that to the contractor. So I know lots of contractors who have used that. And it's typically, though, requires a company like yours probably do it, because I think you have to do an energy model fairly with PE. But it's a super program. I know it's used a fair amount. And you're right, you can stack them.
Yeah, you can stack them. And so that's a wonderful way to see a lot of value, is really kind of lining up all these incentives together and making sure your goals hit all of them. But the 179D program in particular is really valuable. It's one that's been around for 20 years, but yet we still meet people all the time who are saying, this is the first time I've ever heard of this. In the case of a government or a tax-exempt building, they don't pay a federal tax, right? So a deduction won't do them any good. And this program allows the allocation of that benefit to go to someone who helped create the technical specifications for that project. And so the value doesn't get lost. The value then can go back to the folks that are helping implement this project to hopefully incentivize really evaluating good energy efficient projects. And in some cases, we've got clients who helps get that benefit back to the building owner, right? They might share in that benefit in one way or another. But there are ways for everyone to walk away a winner. The nice thing, though, is that there are programs on the federal side, thanks to the Inflation Reduction Act, that can go directly to a government building owner, as long as it's not federal or a tax-exempt building owner. So they actually get a check in the mail instead of a tax credit. Now, that's for very specific technologies, but there are programs still available.
Yes, more questions. Oh.
Thank you. I'm Steven Barbeau. I work for Callaway Golf in Carlsbad, and we use a energy management program also that has helped us get incentives over months. So I can vouch that this actually works, and that actually helped us run our building, or helped me run the building, I should say, more efficiently to save over $1 million in utility costs, just last year alone. But my question is like, I like the idea of AI coming in to help me manage the facility, and where can I find that kind of stuff to present to my company? Say, hey, listen, I'm only one man doing this. And yes, we have actuators and we have chillers and boilers and all this stuff that I have to service and manage on a daily basis. But where can I find that program to implement into our control system to help me find all the bugs and correct all those bugs?
Well, my CEO can give you a card.
So you are actually the operator who's going in and fine-tuning it.
I spend 90 minutes a day going through my whole system, just making sure things. I don't know if I need this. Does everyone hear me? But I have to go through my system every single morning when I get to work just to make sure everything's running the way it needs to. And like the gentleman said, I have an actuator that can go down on my hot water loop at any given time. My computer says it's working, but is it working? Is my supplier sensor working? Is my outdoor sensor working? So turn my economizers on. So it's like there's so much I have to look into, and being only one man, if I had AI helping me with this, it would just make my life a lot easier every single day.
Yeah, really, it's get the data you want first, right? Because, like you said, your computer says it's working, but is it? You need that real-time data. So having that, and then piecing through what is active that you as an operator have to look at versus what's the data that it's okay to let the AI run, and let it go. And it's going to make sure that it's optimized. It's going to make sure that it's running. You can set it up to say, hey, if it's not running, try it another 3 times. If it still doesn't work, let me know. But it's really, that's you giving it the context and then just letting it run, which is saving up your time so that you can focus on those more active operational tasks.
Awesome. Thank you.
I would just add, I assume you have a BAS, correct? Yes. Okay, so I would say that you first probably need FDD first because, AI is not going to fix a broken actuator. I can assure you of that. It's not going to. That's right, exactly right. So that's important because, again, things will break and AI won't fix it. They may be able to tell you it's broken, but FDD probably does a better job of that. So I would do that first. There's there's literally 30 companies doing FDD, so it's a very common one. Way less on AI at the moment, but there's a few of those. You know what I mean? So.
Broken stuff is 20% and AI optimization is 80%.
Oh no, absolutely. I mean, you need both. Don't get me wrong. It's I used to say, because I was really enamored with FDD for a long time, and I used to kind of lead with it. Now I basically say I lead with optimization and follow with FDD. They're both very complementary.
Yeah. Hey, Greg Tycho, TBL Technologies from New York City. Just want to say I love the discussion on like the focus on the operators. We just did like another session where the workforce training gap, and I spend my time just talking on the operators. So I just love hearing this kind of stuff. And I'll open this question to you too, Stephanie. But oftentimes we're saying the gap is from maybe not knowing what's going on. And really, I guess I want to hear maybe if you guys have any personal stories or more stories about what was the hardest portion of or getting an operator on board. Terry, you mentioned Guideline 36. I'm on the working group, so I feel like a lot of my job is just hey, here's a really dense 500-page document, and let me parse it out for you. And it is an effort that we're going to be doing, making this bite-sized chunks of digestible parts of Guideline 36, but just to make the question broader, how are those stories? Probably the most difficult ones you've had, and the successes that kind of resulted from it. Thank you, guys.
I'll let my panel start if they want to.
So you said you're from New York City?
Yes.
Okay. Well, I will say.
I know you, by the way, Tara.
Okay.
We're
We do some work in New York City, and there's. You're familiar with CUNY Building Performance Lab?
Yeah.
Okay.
Paul and Brianna.
Yeah. Okay. They're excellent folks in doing training for building operators. We work with them for like years, and it's a super program. I definitely think operators. The training and we need training in general because a lot of the good ones are retiring as well. I've seen operators in New York City that have been in that building for 30 years. You don't see that in any other city. I mean, it's pretty amazing. So they know their buildings really, really, really well. We've had a building recently. We're doing one right now, and it got sold up top, and the facility managers are semi-cooperative, but you're right, it's not their focus. And so, like for instance, in August, they overrode their buildings 24/7 because there was a heat wave. Recently, they did the same thing again. We're trying to convince them when they do that, don't override the DOAS units because they're 100% outside air and they're incredibly expensive to operate. They just override everything. And we're like, oh, come on, really? That's so we had that recently, and they're still fighting us on that. We're like, okay, I get why you need to override. You had a frozen pipe, right? You have to protect that. But overriding a DOAS, which isn't really isn't doing thermal control, is just, whatever. And so we're fighting that battle. We just give them information. We've had operators at a very large high-rise in Philadelphia when we implemented chiller plant optimization, and it was doing active condenser water reset. And they would call us in the dead of summer when it's 90 out and say, why are our fans not running at 100%? And we're like, because it doesn't matter. And we had to prove to them. We had to run the fans at 100% and show them that the condenser water is not going to get any lower. You're just wasting energy. And that's a guideline 36 standard procedure. But when you actively reset temperatures, even like another super one is optimal start. So it's an algorithm. I think it's the best algorithm, best single algorithm that there is. It's been in the BS industry for 30 years. You know how many buildings I see implementing optimal start? Less than 10%. But because building operators love to see everything start at 5 o'clock or 6 o'clock or whatever time that they will walk around and hear all the fans running. And when it starts starting at different times, they don't like it. It's they have to get used to that. And typically, we try to tell our clients, give these guys some energy efficiency incentive. They're really incentivized on thermal comfort only, and you can do both. We try to tell them we can do both, but incentivize them in some way or other. Build dashboards that put energy efficiency KPIs, on top. So when they log into the BAS, they're looking at, their energy use this week compared to last week, or this week compared to normalized last week or last month. If they see it, often and they're incentivized, it's much easier to get their buy-in.
I have thoughts, but I actually want to see if Scott wants to chime in because he works a lot with the operators and they seem to be very responsive to not turning things off. Thoughts?
Are you incentivizing them? Give them a little.
I'm not quite sure what you're getting at there.
Well, I just feel like we're talking about it from like the BAS and the incentives and, you're working with these operators, you're sending them a text, be like, go check on this. And they're not like, screw off, I'm too busy. So there's like a relationship there.
Yeah, well, like when it comes down to particularly apartment buildings, it's very simplistic. It now comes back to texting and stuff. So, and it's all going to depend on the person working in the building and whether they care or not. So it gets, I'm assuming AI doesn't have feelings. So
you don't know, maybe it does. Maybe it could.
So I think when we get to a point where there's something that's just determining their best course, would be great. But until then, we are dependent on humans and making their choices in buildings. I've been into a municipal pool where the operator wanted to show me something and he bypassed about 27 different alarms to get to the page he wanted to see. As I sat there watching him click, 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 click. So humans can be a little bit more challenging, shall we say.
Yeah, I think maybe just one thing to add to that is I've found that in order to get operators engaged, you first have to reduce their load. And so if you can go in and show them that the energy efficiency or the AI or the fault detection is actually reducing their load, now all of a sudden they have capacity. You go into an operator who's like fully busy and you're like, I have this great new heat recovery chiller. It's way more complicated than your boiler. You're gonna love it. Absolutely not. Please.
Digestible 2-pagers is like we'll be like simplifying a lot of that language, and we'll be like showing like case studies like, hey, this is like energy usage, like so that way it's really easier sell to like a owner, but mostly the operator too.
Yeah, and maybe just one more note, just so you know the resources that are out there. We're based in Canada, so grain of salt, but there is a lot of work being done around through the city of Vancouver and through Building Owner Management Association, BOMA. So they are currently we've just developed guides for nonprofit associations for operators, like, hey, you have this new equipment, you don't know how it works, you don't know what to do. Here's a 2-page document. And so we're now developing an equivalent for operators in more complex BAS with more complex systems. And that's being rolled out in parallel with contractor guides. So it's like, hey, contractor, here's how to commission it. Hey, operator, here's how to check that it was commissioned, and here's how to troubleshoot it. So those are helpful. We maybe have time for one more question.
So this is for Danielle. Okay, it's for Danielle. Fault detection is probably like the kindergarten of AI. That's the way I no, mean anything. But fault detection is fault detection and diagnostics, and you can have some nuisance alarms and all that. And so AI seems to be a great new way of doing things. But like in the social realm, they're talking about guardrails, right? What are the guardrails when it hallucinates and doesn't do the right thing? And I don't know the nuts and bolts of AI. I don't know if it's a large language model. I don't know how it gets done. And it's kind of nebulous. Maybe you could clear some things up for me, how those things happen.
Yeah, so I love that question about guardrails, about specifically for fault detection, I think is what you're referring to. AI is about as broad of a topic as English or languages. I'm going to expand it into languages because you can have AI that needs a large language model. And that does hallucinate, to your point. We can have AI that is physics-based. So when something is moving, it tracks the movements. And in that situation, it's a reactive AI model where it's tracking what's happening and it's getting a feedback loop in real time. There's not a lot of hallucination because it's a feedback loop for that particular moment. So what I would advise you is know what AI you are working with. So our particular AI, we don't use guardrails because it builds a model that is based 100% off of what a human has already programmed, and it watches it for 2 weeks. And it says, okay, this is going to be the best starting point. And it uses that average. Let's say our temperature for a chiller condenser water set point should be 60 to 80 degrees. That was the absolute low, and that was the absolute max that it ever hit. So it says, all right in the middle, 70 degrees. That's the starting point. I'm going to start making adjustments that are just micro adjustments off of that starting point and see what happens. And it teaches itself over time. So our particular type of AI, we call it iterative learning control in a frequency domain, is based off of one point and then learning from that. It's building its own model over time. Versus something that is using a large language model that you are expected to talk to and that needs to understand human communication. And it has to figure out, if I say garbly-gook, what does that mean? And how can I put that into a sentence? And it uses it wrong. And then it tells the president of Korea that garbly-gook is a real American word. So hallucination applies to a lot of types of AI, but it doesn't necessarily apply to every type of AI. So I would say that as you are investigating different solutions, talk to the experts in that product, talk to the people who have created it, and if guardrails are something that concern you, ask them, what are you doing to make sure that my AI cannot hallucinate, that it can't do anything out of the bounds of what I would like, and how do I apply my knowledge and my wisdom into what the AI wants to do? Because the AI right now is at a point where it has autonomy, but it's autonomy that's guided with the context that we gave it. So that's really what I would say.
Think Tesla full self-driving unsupervised. Just took the safety drivers out of no safety driver. Twice as safe, half as much on your insurance. If that hallucinates, people are going to die, and they're going to go out of business with that product. So to Danielle's point, it's important to understand what model the AI is using and who built that model. So what's ChatGPT's model? It was built off of the entire internet, and that's people. If you ask ChatGPT right now what's the perfect condenser water set point, it would faithfully say outside air wet bulb plus 5 degrees, because that's what we all taught it. Our AI is not built on a human model. It builds its own model. So you got to look at the model, and you got to look at the source of the intelligence.
All right, we are over time. Lots of good questions. You can come talk to the panelists if you have a couple more minutes. Otherwise, you are free to go. And the next session in here is going to be how heat pumps fail. So it might be interesting.
Thanks, all.
Good job, team. Sorry, I didn't ask you questions because I knew we were just going to get them.